Oh, I saw your bottle then. I have a bottle.
Test. Good. All right, I'm going to test this in too.
Good turnout for the end of the day.
Yeah, it is. There we go. All right, thank you everyone for joining. Very last session of the day. Should be a pretty interesting discussion. We have here 4 experts representing 4 very different points of view on graph data standards. So the new and exciting news is that GQL has recently been released, and I'll let Alastair talk about that briefly before we get into the actual discussion. But we also have Deborah McGuinness, Tetherless World Chair at Rensselaer Polytechnic Institute. There's a fair number of other RPI people here, kind of representing Semantic Web and also various aspects of AI. Molham Aref is the CEO of RelationalAI. And we'll talk a little bit about what they call relational knowledge graphs, what I would call hypergraph databases. Or Alastair from Amazon Neptune, he gave a really interesting talk yesterday about unifying property graphs in RDF at the schema level. Is also working on RDF star, I believe, and working toward an RDF 1.2. So Alastair, if you'd like to give us just a quick update on GQL, I think that would be pretty helpful.
Sure. Well, I guess one of the most important things about GQL is that it's an international standard that comes from the same standards committee as SQL. So this is the first time in about 4 decades that the SQL standards committee, WG3, has worked on a different standard, and one that's explicitly based on a different data model than the SQL tabular data model. It's also a standard which interacts with and is related very closely to SQL in various ways. And there is a part of SQL PGQ, property graph queries, which in effect quotes a common graph pattern matching language that is also part of GQL, but does use it within the context of SQL using graph views over tabular data. So the GQL language itself is independent of implementation, as these kinds of standards should be and generally are. It could be implemented over an existing SQL database, or many other different techniques could be used, but it's based around the property graph data model. So the standard standardizes the property graph data model, or at least provides a standard view of the property graph data model. It includes both catalog and schema capability. So there's a notion of graph type, which enables one to prescriptively determine the nature of a graph with respect to a type with a fixed set of node types and edge types. It contains DQL in the form of this graph pattern matching language. This is derived industrially from prior languages like Cypher or PGQL from Oracle, or work that was done within TigerGraph. There are multiple inputs that went into this standardization process. It's also derived from an academic standpoint from a number of different arenas of research like conjunctive regular path queries and GXPath. And as I said, it's shared between GQL and SQL. So it's a very powerful capability to effectively determine the existence of or to extract subgraphs from a graph. Finally, it's a full database language. It's not just a query language, so it has DML, the ability to insert, delete, and amend, and it also supports transactional updates. I guess in summary, we set out, there was a W3C conference on data management standards back in 2019 that I co-chaired. one of the things that we said then was the property graph world is way behind the RDF world in terms of standards, and we need to level up. If we level up, then that will actually also enable us to talk about how to relate or possibly unify these two worlds, which I think we'll come to. I think what has happened here, after a tremendous amount of effort internationally and from many, many different companies, many large community of people who sought to support this, including in academia, we've got to the point where the property graph world has a solid, serious standard that also creates a unification over what was previously a disparate landscape.
Yeah, I mean, like you said, for many years, property graphs kind of lagged behind RDF in terms of schema. I think we'll get to kind of other areas where maybe property graph still has some catching up to do, but with GQL, you know, that style of graph for the first time has a schema language to rival RDFS, and it'll be interesting to kind of compare the two. But I'd like to kind of go down the line and continue with you, Aura. If you could talk a little bit about the work that's going on in RDF star and working towards the next version of RDF.
Sure. So just for those who don't know, I'm the co-chair of the RDF star working group at W3C. And we've been working now for about a little over a year and a half. The original motivation for RDF star was to make it easier to, as we say, make statements about statements. So the mechanism that earlier we needed the old RDF reification to do, and that has turned out to be cumbersome and people don't want to use it. And so RDF star is really an effort to make it easy to make statements about statements. And there are a number of use cases for this. Obviously, one is the ability to annotate statements that have been made for purposes of, let's say, provenance or something like that. But we're crafting this in such a manner that it also allows us to talk about hypotheticals, so that we can say things like Alastair believes that the moon is made of cheese without having to say that the moon is actually made of cheese. So because in RDF, basically, a statement that you make, that you assert, as we say, is sort of tacitly considered to be true, considered to be a fact, and sometimes we want to talk about things that are not facts. So this is possible, and but then of course this exercise is not necessarily terribly easy because we essentially take existing RDF semantics as sacrosanct. So we don't want to mess with things that are already in existence because we don't want to break existing applications. So backward compatibility is very important. So given this, there's some fun aspects of this. So for example, let me give you an example. Let's say that I make a statement that Elizabeth married Richard. Okay, so that's an RDF statement. And then I want to make a statement about this statement, and I want to say that this happened in 1964. Okay, so far so good. But now Elizabeth goes and divorces Richard and then marries Richard again in 1975. And now I want to say that, but I can't, because an RDF graph is a mathematical set of these triples, these statements. So I can't have two identical statements about which I could make different statements. And so this gives rise to something that we call triple occurrences, and gets us kind of around this this problem. But that also aligns us property graphs in the sense that now we can really have identical edges between two same nodes and make different, put different properties on them essentially, because a statement about statement is essentially the RDF counterpart of property graph edge property. Now RDF is going to be more expressive because these edge properties don't actually have to be scalar valued properties. They can be edges to other nodes. But there's still work to be done. We don't yet know how to use this mechanism when defining ontologies. I'm not entirely sure anybody knows. And so these use cases where what we're doing is some kind of a cross-cutting aspect like provenance, that's easy because that is then not part of your domain model. But how do you use this mechanism so that you actually build it into your domain model? We don't quite know yet, and we need vocabulary for that. So there's still work to be done.
All right, thank you, Laura. And we will circle back to some of those issues later on, statements about statements, modality, and so on. Molham, I don't know if you want to talk more about SQL or about the REL language, but I thought it was really important to bring kind of that relational knowledge graph voice into this conversation.
Okay, maybe I think it's safe to say I'm the least visible person on this panel, certainly to this community. So maybe I can establish a few points of view here. So first of all, we at RelationalAI really, really appreciate and love, dare I say, knowledge graphs, and we want them to be used way more broadly than they are today. Okay, so just in case anyone is confused about that. And the things that we appreciate about them, and that I appreciate about them, is of course the sort of adaptable core graph-based data model where every relationship is modeled directly. Okay, and that gives you a lot of dynamism. It gives you dynamism around structure. It also, the model allows you to bring knowledge close to the data, and you can express knowledge declaratively in the form of rules and queries and so on. And that gives you dynamism around knowledge. You can adapt what you know about something, and that's very, very important in a lot of just a lot of practical use cases. These things are missing in a lot of systems that we see built in the enterprise. Okay, and so specifically, people have these triple data modeling technique, entity attribute value, or a meta model that's very high level node relationship type meta model. Okay, so this dynamism is fundamental and it's important, and the real world changes all the time, and if you don't have systems that can change easily, it's not good. And in fact, I think there are tons of proof points out there, people approximating knowledge graphs. I don't know how widely known this is, but the core structure in Salesforce, so one of the world's most successful application companies, also application development platforms, is a 4-column table that has the first column is tenant, next column is entity, and then attribute, and then value. And everything is built on top of that 4-column table. They use an Oracle SQL database nominally, but it's mostly to store a 4-column table. Okay, so I think we can point to that as an example. Now, of course, they don't talk about it as a knowledge graph, but we recognize the knowledge graph in there. And then, of course, lots of people build platforms and applications using JSON as a way of representing dynamic structure and so on, because different JSON documents can have different fields in them. Okay, so hopefully I'm not just making an empty statement about why we love knowledge graphs. I'm explaining to you why I think they're important, and in practice they need to be more broadly used. Second, I also want to declare that I really think standards are important. So we are privileged in that several of my colleagues are on the standards bodies that Alastair mentioned, and we proudly voted for GQL, and we also voted for SQL PGQ, which I think is also another important thing that we shouldn't forget, bringing sort of graphs more directly into SQL. Having said that, And of course, we appreciate the semantic web and the standards there and all of that. Having said that, I think we all have to keep in mind that standards are a means to an end. We like standards because they hopefully help us with adoption. They create safety. They create a fungibility, both in terms of skill sets and IP. Okay, so the point of them is to promote adoption. And I think they're maybe necessary, but they're not sufficient, because if having standards was enough, everybody would be using knowledge graphs. We already have knowledge graph standards, okay? So the key thing that I'd like to highlight for relational AI, and I'm almost done here, Josh, is we really think the key to adoption is meeting people where they are. And the reality of our world is most people are building data management systems on SQL-based solutions, on the relational model as it evolved since the early 70s, based on Ted Codd's original paper, which sort of established a correspondence between the relational calculus and the relational algebra. And at the time, when it first came out, it said nothing about SQL. It said nothing about third normal form. It said nothing about, SQL databases as they became. Okay, and so our thinking is, what's missing from SQL systems? Like, what can we do to SQL-based systems, since this is where everybody is, to make it easier and easier to adopt knowledge graphs? Okay, is it support for highly normalized data models? We are coining the term graph normal form, variation on 6 normal form, which is sort of the ultimate, most atomic normal form. And you don't have to squint that hard to see that's basically just modeling the world as graphs and hypergraphs. Okay, what's missing in terms of knowledge representation? Because that's also very important. So can we get to widespread adoption of knowledge graphs by thinking about this in a sort of a meet people where they are problem, and how can we adapt these systems that are highly proven, highly scalable, highly secure, to have millions of hours of engineering went into them? Can we adapt them so that people can get the benefit of knowledge graphs without having to create a copy of the data and move it into a specialized, labeled property graph or other kind of things? Okay, and of course, if we have such a thing, we can map Sparkle and RDF to that, and we can map GQL and other graph standards to that. But the starting point for us is, how can we meet people where they are? And the reality is, people are on systems like Snowflake and BigQuery and systems like that. That's where all their data is. How can we bring knowledge graphs seamlessly into that world?
Good, thanks very much, Molham. And after this, we'll start kind of comparing and contrasting the different approaches to standards and models and identifying gaps and so on. But last but not least, Deborah, I thought you might want to say a little about OWL, but you're welcome to speak in anything you'd like to.
So I love OWL, but of course I'm a little biased given that I'm one of the co-authors of many of the OWL documents. But I thought maybe, and OWL emerged because we needed more expressivity. The knowledge representation and reasoning people in the world, or some number of us, felt like we needed more expressive power in some of the languages, and then we needed some standards so that we could interoperate. And then we determined those constructors according to what was needed from use cases, but also what could be computationally tractably managed. So that's kind of where my perspective, and I think many of our perspectives land with how OWL emerged, and the slightly more expressive RDF-based representation languages emerged, and then the applications and the query languages around them. But I thought we might pick up a little bit on meet people where they are, and I thought we might pick up a little bit on one of the questions that Josh provided to us of what could we learn from our areas. And I love OWL, I live and breathe OWL, I use it everywhere, but I don't know that the community that I represent, the OWL community, really met people where they were, because we were a little bit more theoretically oriented, and we had a little bit too much of the perspective of created and they will come, rather than here's a great tutorial, here's the use case, here's even the economic value of the use cases. Came up in the healthcare and life sciences day of show people success stories and show them in a way that speaks to them. So get them easy on-ramps, and there's some adequately easy on-ramps with some of these technologies, maybe a little bit less so of the stack that I represent a little bit more than some of the other people on the panel. But we could use more. And then the interoperability, one of the things that Alastair said was if his side of the world kind of came up to some of the other side of the world, then maybe we could now talk about the interoperability. And that's where I really think our field needs to be going. So maybe I'll stop with that for the moment.
Okay, thanks very much. Well, I'll actually segue into another question then, which is about interoperability. What are the thoughts of all of you on whether there should be a single unified standard for graphs, or whether these individual standards just continue to exist and thrive, and we should really be aiming for interoperability among them? I'll start back at the end of the line with you, Alastair.
Yeah, it's an interesting problem. I mean, I don't know how big the market is for truly having a single underlying model and then being able to put personalities on top of that model that reflect these historical traditions. I mean, certainly AWS Neptune has that problem as a product. In fact, it's something they need to deal with. More broadly, it feels to me like building successful bridges at various levels, whether it be data interchange or schema, or being able to embed one query language in another if you've got enough restrictions on the model, and so on and so forth, are probably steps that are going to have to be taken at some level as part of this this sort of project of interoperability. And I guess the other thing, which to be blunt, is are the two communities going to actually, they're already not equal in terms of market share. The question is, how long is that duality going to go on? Now, probably the answer is data standards are incredibly sticky. The moment people create data repositories, build applications around them, you're in for the long haul. I mean, if you look at that spaghetti diagram that Gartner produced recently about the different databases and their share in the market, I think IBM's still sitting at number 3 or something. And IBM is not an innovator in any shape or form in the database world anymore. It used to drive everything; it drives nothing. So I don't know what exactly how big this is. That's, I think, is there. So I think there are sort of non-technical questions that underlie how this is going to evolve and the significance of this issue. It's certainly good to facilitate it, to make it possible.
Sure. Thanks, Alastair. I'm also really curious about your take on this, Aura, because you've said, I think in your talk yesterday, that the split between RDF and property graphs is hurting the graph community. Can you elaborate on that?
Yeah, I think it is. I mean, this is graphs. They're still kind of a nascent market, and there are a lot of people who really could use graph technologies, but don't know anything about it. And we sort of think that the group of customers or potential customers who already know about graphs and know what they want to do is much smaller than the group of potential customers who, once they get educated about this and understand what you can do with graphs, could jump on this and make use of graphs. Now, in the Amazon Neptune graph database team, we have this long-running project called OneGraph, and it's sort of, the original motivation is exactly this so-called problem that Alastair is referring to. It is a problem. So Neptune supports both RDF and labeled property graphs. And this is great because we wanted to give our customers a choice. Now, the law, unintended consequences, unfortunately says that now the customers have to exercise that choice. They have to choose when they start using Neptune, whether they want to use RDF or labeled property graphs. And when they choose, that sort of nails down the query languages that they can use. If they choose RDF, their query language is Sparkle. And on the LPG side, we now support both Gremlin and OpenCipher. They don't always make the right choice. And later on, it's really difficult to walk back that initial kind of design decision, if you will. And so for this reason, we really wanted to kind of make it easier for the customers to basically use both technologies the way they would like to use them. I mean, we have customers who expressed great interest in they've said that they absolutely want to use RDF, but they don't like Sparkle. They want to run OpenCipher over RDF. We see no reason why that couldn't be done. Similarly, there are features on the RDF side that people often kind of end up reinventing on the LPG side. Predictable merging of graphs, strong identifiers, federated query. There's generally sort of the easy interchange of data. Super easy on the RDF side, often an engineering proposal on the LPG side. So we sort of devised this idea of what we call graph interoperability. We thought that there could be one graph, and then you could look at it as RDF or look at it as a labeled property graph, and you could mix these query languages. And we're pursuing that. We have an actual implementation of OneGraph already, but it's kind of not exposed yet. And so over the course of, I don't know, maybe a year or something like that, we'll be bringing piece by piece the missing parts of this, so that eventually we'll have this kind of true realization of graph interoperability. I mean, I really want to run Gremlin over RDF. I like Gremlin, and but I'm not a huge fan of labeled property graphs because of these aforementioned great features of RDF. So I'll be very happy when that happens. And
thanks, Ora. I'd like to dig into that a little bit, and we'll get back to interoperability. But what do you think that turns users off about Sparkle, the typical developer?
Yeah, I really would like to know what that is. Well, okay, let me tell you what's wrong with Sparkle. So first of all, Sparkle is not a recursive query language. So if I have a recursive query, I can express it in Sparkle. I mean, case in point, if I want to compute the concise bounded description of an RDF node, there is no actual Sparkle's select or construct query that I could express that does that. Now, most triple store implementations actually give you the opportunity to compute that using the describe query. But what if I wanted some variant of the concise bounded description? So that's one. Number two, Sparkle doesn't really have a concept of a path as a sort of a first-class citizen, if you will. Actually, the original version of Sparkle 1.0 didn't have any capability of doing any kind of path queries. And I spoke with the working group at the time when they were working on it, and I said, look, you have to have paths. And this is what they told me, and I'll quote them verbatim. Paths are not a use case for graphs. Seriously, they said that. And I'm like, you guys are clueless. And sure enough, Sparkle 1.0 was a disaster. Sparkle 1.1 adds property paths. So now you can basically express paths that are sort of like regular expressions over the predicates in the graph. And that's a great improvement. But the problem is that you can do path traversal. Once you're done, you have no way of finding out what the path was. And this comes up all the time when I talk to customers. And so that's one of those things that we wanna fix. And we could fix it either by waiting for W3C for who knows how many years to get their act together, whether they even would, or we can just tell the customers that, hey, just run OpenCipher over RDF and do it.
All right, thanks. Back to interoperability for just a moment. Molham, any thoughts? Obviously, you've built your knowledge graph solution on top of an existing standard. Maybe you can tell us what you think of that paradigm vis-a-vis, say, OWL and RDF and kind of the different features that you have there, universal namespace and so on.
Yeah, sure. So again, the goal here is we have a cool idea. We have a cool way of thinking about systems and modeling systems. We want adoption. If you look at the last 50 years of our industry, the only time you get adoption is when you have platform transitions. So you had IBM, Sperry, Burroughs, a whole bunch of mainframe companies. And when you saw the shift to mini computers, you saw most of those guys go away, and the giants of that era became the dinosaurs of the next. Mini computers, you had DEC and HP and Wang and Data General. I don't think any of them exist. Microcomputers, we all remember how dominant DOS was and all of that. Again, platform transition. We also remember how dominant Lotus 1-2-3 and WordPerfect were. Platform transition to Windows. Who uses Lotus 1-2-3 anymore? Okay, I shouldn't say we all. I mean, you have to be my age to remember. And then cloud computing. Like, who would have thought? An online retailer is going to basically eliminate Sun and Compaq and every hardware company out there. Okay, so these platform transitions are really important, and you're not going to get anyone to change their behavior within a cycle. It's going to be across cycles. And so I think we're in the middle of a platform transition right now, and I think it's a transition to this emerging category called the data cloud. And I think Snowflake and Microsoft with Fabric and others are going to be rethinking or encouraging us to rethink how we build applications. And instead of building them on the cloud, the raw cloud, they're going to say, hey, look, we're giving you a data platform, and you can rethink things in a data-centric way. And you should re-platform on Snowflake or Fabric or whatever data cloud ends up leading. My money's on Snowflake right now. I think they created that category and they're leading it, but who knows? So I think this is where you go. Like, if you want the people to change behavior, they're going to be rewriting their stuff to run on the new platform. This is where you can get them. Okay, how do we introduce knowledge graphs into that transition, because they're already going to be replatforming? Okay, and that's, I think, the opportunity. So for us, we see that transition. We also see people now talking about semantic layers. In fact, last year we worked with the Knowledge Graph conference team, and we invited companies like DBT to talk about their semantic layer. We invited Morgan Stanley to come in and talk about that, and we raised awareness for what Goldman Sachs is doing around Legend. So people are actually talking about semantics, like for real in the enterprise, broadly speaking. They're just not always talking about knowledge graphs in that context. Okay, and so our approach has been to define REL as an intermediate representation for knowledge graphs, and to make it possible to basically create a knowledge graph using whatever semantic surface language you want. It could be the Semantic Web, and we're doing that at a customer right now, where we transpile from Sparkle to REL. It could be something like Legend. We contributed that to the open source. It could be Python. You can give people a Python library that lets them define a knowledge graph in the same way that in PyTorch and TensorFlow, they define a machine learning execution graph. they're not really programming in Python. They're using Python to set up the artifact that they want to set up. And if that gets them over the hump, then that's great. And we shouldn't have religion about syntax and about things like that. It should be, again, putting the power of the mental model in the hands of the masses. So I look at it as like a window has just opened. People are going to be rewriting a bunch of stuff onto Snowflake and Fabric and other data clouds as a platform. And we need to go there and make sure those communities are empowered and encouraged to use knowledge graphs. And yeah, I don't know how relevant interoperability is going to be to that community.
Got it. Well, I was just about to ask. You mentioned transforming Sparkle to RHEL. Can you say anything else about interoperability features? Is there anything that involves property graphs or going back out to RDF or anything like that? And if so, what kind of approach that you've taken?
I'm like the village idiot in my company, so I can't get into too much details. But Leonid and Marcelo are here, and they're very involved in making that translation. And we have other colleagues that work through the details of that. But RHEL is very, very expressive. And again, we revisit the relational model from first principles with the idea is that can we capture polynomial time and NP as computational classes to make sure that we can map whatever semantic technology people are using to what we do. Okay. But when we have a big announcement coming up here in a month at the Snowflake Summit, we're not going to even launch with RHEL. It's going to be, again, meeting people like at Python and SQL. That's what they like. That's what they like to use. And having any delusion about that is not going to help. So it'll be a Python library that lets you set up a knowledge graph and a whole bunch of SQL interop. And at the core, there's going to be this RHEL intermediate representation that Bob spoke about 2 years ago, et cetera. But we're not like, you don't get points for getting people to pick your syntax. You get points for getting people to build knowledge graphs and build real world systems, and they get the benefit from the abstraction and from the model.
But doesn't that contradict what you just said about platform transitions? I mean, look at SQL. SQL has survived all of those platform transitions. The companies that defined SQL no longer drive the standards or drive the market, but that standard has enabled those transitions. I mean, the hardest thing you can do, if anybody's done it, and I have more than once, is port from one database to another, even with allegedly the same model, right? And allegedly a standard. So I think that actually standards in this environment are absolutely critical to surviving these transitions, right? And I think that's a real problem for genuine usage on an enterprise scale of databases.
Look, you have two kinds of standards. You have standards like in the standards body sense, and sometimes those are very effective. And SQL is a great example of that, right? And Oracle was great at first defining the standard, SQL as a standard, because IBM does it. And if IBM does it, that's the de facto standard. That's how we got into SQL to begin with. And remember, there were so many alternatives to SQL in the early days of the relational movement. And I would argue Cypher, that became effectively a de facto standard. And a lot of the ideas from Cypher, I think it's fair to say, are have been made officially standard through GQL. But Python.
It's interesting on that one, Molham, because having been involved in the genesis of GQL and many discussions, with different vendors, one of the reasons why Cypher has become a de facto standard is because the people behind Cypher said that they were going to create a de jure standard, and it was going to be an official international standard. They were going to give up their proprietary hold over Cypher, and that meant vendors were prepared to invest in it because then they knew that there was a real standard coming. And so I think official standards, even if they're not precise in terms of their implementation, like many variations and dialects of SQL, can be enormously important.
I agree, Alastair.
Launching, taking us to a different stage in terms of the use of graph.
I agree. We voted for both of.
I know you did.
Yeah. So I know it's more fun if we disagree, though. So my point is, Python is a standard. SQL is a standard. And what are we trying to get? What are we trying to accomplish? We're trying to get people to adopt knowledge graphs. And if Python and SQL are the right vehicle for that, those are good standards to follow. One is a standard, the other is a de facto standard. I don't think I can make those statements and I don't think that means that I somehow don't think standards are important, but like standards are a function. The fact they're a standard is a function of people using them.
Do we really think that SQL is the best standard for graphs?
Again, in an interop sense, if I can visualize my graph as a 6 normal form or graph normal form relational database, and I'm getting to it via a SQL-based system as a set of views that interoperate with my tables, and when I add and remove something from my table, it shows up in my knowledge graph. Yeah, I think SQL is part of the story.
We'll get back to SQL versus GQL, but I wanted to give Deborah a chance to speak here. The semantic web is all about standards. It's all about, well, all about interoperability. I wondered if there's anything else you want to add.
Yeah, it is all about standards and interoperability, but you know, I am not always the most dominant voice in the semantic web community, but I'm a consistent voice with. We need to get on-ramps for people to get started. It needs to be relatively simple. And then we need to have bridges to get them from where they started to something that makes sense. Like Ora said, some people are making some bad choices. Let's try to get a bridge to help them get to a place where they're making a good choice. So, you know, I think that I am a supporter of standards, although I've experienced the pain of being on many standards committees. And actually, after some pain of some standards committees, I've co-run or co-chaired best practices working groups to use those standards to help people get those starting points and on-ramps and some accessible tools. And, you know, I think the world has just seen what happens when you have a low barrier to entry. LLMs and the chat GPTs of the world, super low barrier to entry, right in a natural language, and you get something back that's interesting. You know, it might be wrong, but it's often interesting. And you don't have to do anything. You don't have to be technically savvy. So I think the communities that I represent, we have not gotten to that level. And actually, I'm not sure that anybody on this panel can claim that they've got that low a barrier to entry. But standards are important. Interoperability is critical, but these low barriers to entry to get started and then the bridges are also absolutely critical. And I don't think as an academic, we don't put enough time into that. As industries often put more time into it, but the community, if we want to take off, we need to spend more time there.
Well, you keep giving me these great lead-ins to my next topic. Gen AI. How does Gen AI affect standards? Because it obviously is starting to affect how people interact with graphs. We've heard, you know, lots of talks in this conference about graph RAG and about you know, generating semantic data and grounding it using ontologies. So that takes out some of the human in the loop. You know, in those cases, you still need a human, you know, a schema expert or ontology expert to design the model, but you don't necessarily need a human to understand how to write the data to the model. Does that affect what we need from standards in the next, you know, in the next few years? If anyone has thoughts on that.
I think that the role of graph standards is only more critical with LLMs because, well, okay, so call me a skeptic, but we're not going to do this with LLMs alone, and we're already seeing graph RAG and generally sort of the interplay between LLMs and knowledge graphs to be hugely beneficial. And so now if that becomes kind of the, I don't know what to call it, the dominant design of the architectures of the future, I think making it so that people have the choice of which implementation they choose for their architecture, that these are interoperable and interchangeable. I think that's important. And also, okay, so I'm kind of an old school standards guy, but I sort of think of a standard as a specification that I can implement, because that's the thing that in a way sort of enables us to have multiple implementations of the same. And I think that's that's really important.
I think language models are a gift to this community. And again, it represent a platform transition, right? And so people will change the way they build things based on, wanting to incorporate the power of these language models. And I think if you have systems that have clear, ontology, well-designed ontology, et cetera, you can now verbalize things about the domain, about your business, in a way that you can present that to a language model so it can do more. As we heard earlier in some of the talks, I do think, people have a much better chance of being able to do knowledge extraction and, making it easier to build the ontologies to begin with the help of a language model. So it really is a gift, and again, should not be wasted by this community.
But you can't have a clearly defined ontology unless you have a standardized ontology language.
Again, pick what works, right? And the point is, I don't think you need to send OWL or GQL or whatever to the language model. You send it the verbalization of what that ontology says.
Well, then you've
Call me a skeptic.
Then you've built the problem you're trying to solve. I mean, you want people to be able to actually interact using natural language, but that has to be translated into something that's precise and deterministic. And the knowledge that's required to actually understand what queries would actually match natural language, what queries are actually possible against a particular graph, and so on and so forth. It depends on having schema. And there are two things I would say about this. It's possible that this is the killer app for graphs, like globally, right? We zoom out. And secondly, I think it really reinforces the point about schema. So the property graph world grew up schemaless, and there's lots of nice things about being able to play and all the rest of it. But if you read anything about how people are actually using LLMs in the process of trying to exploit natural language, or to develop banks of queries, or indeed design schemas based on natural language inputs and so forth, it all comes down to what the schema looks like, how precise it is. And our schema languages at the moment in the property graph world with GQL graph types are just beginning. They're not very precise. They need to be much more restrictive in terms of the precision about the kind of data that you've got. All of that will, I think, catapult forward, the use of graphs in the sort of retrieval to enhance, the antidote to hallucinations aspect.
I might add that I also think they're a gift to this community, but I don't know that they're the killer app. They could be. I think they're more a killer enabler, because the world is looking at our areas now because they've been enthralled with this emerging technology. And it does some cool stuff, but it's got some limitations. And without these precise definitions, you're not going to be able to do reasoning, and you're not going to be able to do deductive closure, and you're not going to be able to find the contradictions that you need to do in critical applications. So I see it as this enabler and a gift. I see it as broadening the base of people who are starting to realize that they need our technologies. And so they played with something that was easy to get started. They got some cool stuff, and then they found some problems. And our technologies can solve a lot of those problems. So again, it's about bridge building. So let them get started with whatever they get started with. Use your phrase, meet them where they are. I'm going to use another one. Get rid of your religion, whatever schema language you think is the only one. Don't sit there. Let them start where they want to, and then show them how where they are might benefit from what you've got, which is the more expressive thing often.
Yeah, so with our customers, in one case, they're using OWL to define the ontology. It's a great choice. But if they wanted to use object role modeling because they prefer that notation, that's fine too. It all, it doesn't matter as long as they're building an ontology, and as long as it's formal and has all these properties. So I want to make sure that I'm not being interpreted as not wanting or not. I don't think that a formal ontology is important. I think it's very important, and it's more valuable when you have language models because it lets you verbalize, what the domain is about.
One of the things is that the natural language is not a particularly precise way to express anything, and But let me give you an example, something I saw this morning. I walked to Starbucks and there was a sign on the lawn that said, do not feed pigeons and squirrels. And I'm thinking, what does that actually mean? I mean, is it okay if I feed pigeons but not squirrels? Or if I feed squirrels but not pigeons? I mean, I could feed squirrels and I could say, I'm not feeding pigeons and squirrels.
Now we know why RDF was such a big success.
We have to be precise in our expression, because what is the purpose of language? It is to communicate, it is to convey some kind of meaning. And if you can't convey the meaning, why are you even talking?
Again, it needs to be formal for sure. But what I'm saying, if you have a formal model, you can verbalize it. You can now say statements like, we are talking in New York City. The language model would take a statement like that more, I think, easily than it would some mathematical equivalent statement.
Especially Boolean connectives. I've done user studies where it's clear that the world cannot use and or correctly.
So that brings up a good point of what is the kind of the ideal level of expressivity for a graph standard, both for humans and for machines. Is it, OWL? Is it OWL full? Is it something very basic? Is it something close to the expressivity of GQL or SQL? What thoughts does everyone have?
One aspect of expressivity, I think, has just been expressed, which is the idea that we have lots and lots of tools, and if we have lots and lots of tools, that's good, because we can deal with many problems. I think actually sometimes standards are sort of analogous to the point that, I'm a bad example of this. Life expectancy is enhanced by calorie restriction up to a certain point, and certainly not below that point. So, I mean, property graphs are an example of that. There was a deliberate constriction of what you can do with graphs. So things like a property cannot be a node or an edge, which means that you can't sort of squirrel the graph all over there. You put the topology of the graph is something that is actually distinct. It's an artificial restriction. From a theoretical perspective, it's abominable. It's unpleasant. But actually, what it meant was that this idea of graphs connected with SQL record-oriented databases and data sets that are record-oriented, and it became possible to think of the relationships between those records in a way which intersected with all the things you can do with graph. And it opens the way to actually using all the aspects or the achievements of graph theory. So I think that I don't agree with this idea that it's okay to have lots and lots of things. That may be imposed upon you by the pre-existence of communities, but what I think we ought to be trying to do at minimum is rob the good ideas from each other to the maximum degree, so that we tend to converge on the same set of capabilities. And the more we do that, however that plays out, the easier it is for users to play in this space. And I think that that's really what this game is about. It means it's like get rid of quell, and there's only one way of doing relational databases. That was an achievement, the extinction of quell. Even if that was, Larry Ellison that achieved it, take that away, it was an achievement historically.
Or I'm curious what you think about this, because you had talked about statements about wanting to express modality, which I completely agree is a great capability to have, to say that this might be true, or that this person said this was true, or this person said it was not true, and so on. But that is another level of expressivity. Alastair is essentially saying constraints liberate. It makes it easier to build systems. You're working on adding additional expressivity to RDF. So I'm curious about your take.
Yeah, I have a comment and a story. I think that, okay, I'm going to quote Jim Handler, who some of you know, who has always been saying before RDF came about that a little bit of semantics goes a long way. So yeah, I like the idea that I have like huge expressive power available, but most of the time I don't need it. And you know, if it makes it more difficult for users to use something like that, then it's possibly counterproductive. About what we're doing in the RDF star working group. So ability to express hypotheticals. So back in, I want to say 1997 or something like that, we're working on the original version of RDF. And we're talking about this mechanism that we call reification that lets you express hypotheticals. And I pointed out that we need a semantic theory for this, right? And I pointed out that if we want a semantic theory for reification, that kind of takes us out of the current system of logic to some system of modal logic. And as soon as I said that, nobody wanted to touch it. And that's why we don't have a semantic theory for reification. And the one important thing that RDF star is doing now is that we will have the sort of statements about statements folded into the model theory of RDF, and that allows us to then do inference over them and stuff like that. And other than that, it's not a huge disruption or upheaval in the world of RDF. We're just, at this point, we're really just tweaking.
Well, in terms of other features or other requirements, we only have a few more minutes. I wanted to talk a little bit about reasoning. And I think I'll go down the line, starting with Deborah, on the importance of reasoning. The semantic web standards, out of everything we've talked about, are the only ones that I don't maybe know enough about Molham that support some form of reasoning. Your thoughts?
Well, reasoning is critical in some number of applications, not all applications, but and similarly, large expressive power is critical in some applications, but not all applications. So just half of an answer to your earlier question of ideal representational power. I don't think there is one ideal. I think we need to have basically kind of an onion or kind of a graph so that things can build on each other and you can use the right amount of expressive power for your application. Similarly, many applications critically need reasoning. If you want to find out whether something's consistent, you need to be able to get to the deductive closure, or at least some of the deductive closure, some of the things that you can infer from the information that you've put in there. And so if we can't enable reasoning, we knock out a wide range of applications. Are there many applications left that don't need reasoning? Absolutely. But I want to be able to do, I'm more interested in the reasoning ones. And also, if I want to be able to explain why I got to an answer, I need to be able to, in many cases, say, well, if you don't do this, then you'll get that bad thing. Or if you do this, you'll get this good thing. And you're not going to get that without reasoning.
A graph of standards, I like that. Molham, your thoughts on reasoning?
Yeah, I couldn't agree more. So I actually agree with Alastair. Like, expressivity to me is not like I have lots and lots of reserved words, right? So we went in our design of REL, heavily inspired by Datalog. You have a few logical operators. You have the quantifiers. You have one structure, which is the relation, and we make it so that possible so that you can have variable arity. So we're not limited to binary relations, basically, and maybe some like one or two constructs for higher order support, so you can get abstraction, so you can write libraries, not have to implement big complicated languages. But the opportunity for knowledge graphs is to take stuff that's all implemented procedurally or in ways that are not easy to work with, and you need to have reasoning so that you can take your average Java program, your average C# program, your average COBOL program, and represent the semantics in the knowledge graph. Like, to me, if we're not expressive enough to capture what's written procedurally in a knowledge graph, it's a missed opportunity.
Thanks. So we have about a minute left. Aura, is there any work, will there be any work on RDF star? And I mean, RDF itself doesn't really deal with reasoning, but any thoughts you have?
So in RDF star, we'll just extend the existing RDF model theory to cover the new features, and that basically means that simple entailment, RDF entailment, RDFS entailment
Just RDFS,
will be extended to this thing. And just to comment to what Deborah said, I 100% agree with what you said, but I would also say that I think we need to kind of broaden our definition of what reasoning really is. I mean, we really now we have only talked about symbolic reasoning, but sometimes, you know, statistical reasoning should be available as a mechanism if that's indeed what works for you.
So we're just about out of time. I'm going to let you respond to reasoning, Alastair, and then I know you had some additional slides. So anyone who wants to stay after for a few minutes and talk about GQL, we'll do that right after.
Yeah, no, I was just thinking about the reasoning thing, and I was thinking a bit more broadly about some of the things we've been talking about. So if we could reorient this world so that it's a bit like sort of Maslow's hierarchy of needs, RDF ought to occupy the top, right? And property graphs occupy the bottom. And that might be a good way of collaborating, because there's a huge amount of stuff that is not needed by so many people that's been done in RDF. And there's a good way of doing what a lot of people want to do in the property graph world. If we could find that way of collaborating, then we wouldn't be trying, you know, I don't think anybody actually wants to trample on anybody else's turf. I actually don't see a vast amount of religion knocking around. But I think that thinking along those lines would mean that we don't try to kill bad ideas, but we try to get the right place for the different sorts of approaches and models and why they've been successful where they have been successful.
Okay, well, thanks everyone for sticking around to the end. I hope you enjoyed the panel as much as I did. So do we have time for Alastair to talk about GQL? No. Okay, done.
Thank you, everyone. Let's thank them again. It was great. This is the last presentation, you guys. Thank you for staying as well. There's one last thing before you go. We have a little raffle. Deborah, do you want to pick a winner?
Sure.
Oh, you have a paper inside, I think.
Oh, I do? Okay, what a.
That's all right.
Okay, I don't pick myself. Patrick Lee.
Patrick Lee. Is Patrick here? Well, no, we'll communicate that. That's all right.
Okay.
Thank you, everyone. We're now going to the hackathon for those who've signed up at Accenture, Hudson Yards. And for those who have registered for the viewing party tomorrow, you will receive an email with more indications.
Take this. And one more thanks to Francois and Thomas and all who helped organize.